It's counting down. So the characteristics of functions that we talked about were that I can't find the page I was on. One of those days, man. It's like I'm missing a page in my book. The characteristics of functions are that for every input value, we have only one output value, right? And that's the main thing we're talking about when we're talking about functions. So it's like in terms of a machine, and the notation that we use is f of x equals. And you hear all the time, well, you could just write y here. Like you could substitute it for y. So if you're solving an equation, say it was like x squared plus 3, you could rewrite it as y equals x squared plus 3 and solve it that way, right? And there's different ways that we test for functions. And I don't know if any of you watched that little optional video that I made where the dude's head explodes, but you're missing out if you didn't. The ways we test for functions, we can test graphically, right? So if I have a function or if I have a graph of something, right? We have something called, so let's say I have something that looks like this, right? That's my graph. Could be this, right? It'd probably be a plus 3. It would probably start up there if I was graphing the actual function we have before us, or equation that we have before us. One of the ways that we can tell if something is a function is graphically, and we can look at it, and if it passes what's called a vertical line test, then it's probably a function, which means if I drop a line anywhere vertically into the graph of this equation, and it will only cross the graph once at one point, like here we've got a point, right? This line crosses at this point, this line crosses at this point, but every vertical line that I put in is only crossing at one point, so that would be a function. Where say I had a graph that looked like great example. Circle, right? Well, that's more like an ellipse. But if I drop a vertical line through the graph of this, I'm hitting the graph of that at 2 points. The graph of that equation gets, so this would not be a function. Hope that makes sense. It's a fairly simple concept. And when you think about that algebraically, we also said that for every input, so this is our input, x, we get one distinct output, right? So think in terms of that. This is an x value, right? This is crossing x right here. So we'll say it's like -2. Well, I have 2 points. When x is -2, I have 2 different points on that graph, right? Where if I look over here and say this is -2, I only have 1 point on -2 where this graph runs through, right? So for each input, my x values, I'm only getting one output here. That's why this would be a function and this would not. Because for my input -2 for x, I have 2 potential solutions. So you can kind of see it graphically whether or not something is a function. So all functions are equations, but not all equations are functions. So some of the things you're going to see in your homework is going to ask you, hey, is this a function? And you're going to look at the equation, right? So here I have x squared plus 3, right? And what it's asking is, for every input, anything I put in for x, am I going to get just one solution, right? And you can kind of look at it. You can make yourself a table, right? And you can go x and f of x, or you could write it as f, x, and y, right? And throw a couple of weird things in for x. Make sure you have a negative. If I put in -2, if I put in 0, if I put in 3, what value am I going to get? Am I going to get more than one solution when I put those in? And I can look at this and I can go -2. If I put in -2 up here, if I square -2, it becomes +4 plus 3, which is 7, right? If I plug in 0 for x, well, 0 squared is just 0 plus 3, and I get 3. But I'm only getting one solution for every value. So I can say that this is a function, right? And that's one way I can prove it algebraically that it's a function, right? Set it equal to y, whatever your equation is, if it's asking you, set it equal to y to determine. When I was looking through your homework, it was also giving things like sets of ordered pairs. So is this a function, right? If I write down a set, and it's going to look like this, and it's going to have a bunch of ordered pairs in it. So one would be like 2A, 3B, 4A, 5C. And the way to tell if an ordered pair is a function is to look at that first value in the sets. Look at your x values. Do they repeat? Does anything repeat under the x? Do I have 2, 3, 4, and 5? Nothing repeats. So this can be a function, right? If I have the same, let's see, let's go 2A, 3B, 4B, 2C. And if you look at this, I have a repeating x value. The first thing I'm going to look at is say, what is the y? If I have a repeating x value and they don't have the same y value, then it is not a function, right? Because now when I plug in 2, I have more than one y solution. So this would not be a function. Right? So the two main ways we've talked about is, do I get more than one output for my input? Right? And the other one was graphically. Will it pass a vertical line test? If given a graph, do I have more than one value in the same spot? Sometimes you'll be given a graph that looks a little bit like, and it'll have like dots, right? That are just points. They're just ordered pairs, right? And it'll say, is this a function? And if I looked at this and it was a better graph, I'd probably say, no, this is not a function, because these look like they're both on -2 at -2x, right? Does that make some sense? Is anyone having any confusion where that is concerned? I'm relying on you to tell me if you are. Look, there's a very close-up view of my tattoo. I prefer this one, though, my little paper airplane. So I'm going to stop talking to you about what functions are now and talking to you now about evaluating functions. So because that's what a lot of your homework is going to be based on, is is evaluating functions. There's a thing in your homework that will tell you how to go about testing them algebraically, where you make sure they're solved set equal to y, and then just see, and you can make a little table like I did just to plug in numbers and see if they work. When you're evaluating a function, when you're evaluating anything mathematically, all it means is plug something in and figure out if it works. Tell me what comes out, right? So let me get this piece of paper over here because I grabbed a few problems specifically from your homework this morning to make sure you got. So let's use the same problem. Here I have f of x equals x squared plus 3. When it says evaluate a function, it's usually going to say at f of 1 or f of 6 or f of x plus 2. Think about this, because this is just your input, right? When we're looking at f of x, it's saying, what is the value of this relation when we're inputting for x, right? So whatever goes in here, we're going to replace x with in that equation, right? And we should get a value. So here I have x squared. I'm going to go 1 squared plus 3, and then I'm going to solve it. Well, 1 squared is just 1 plus 3, which is 4, right? That's all we're doing. We're just inputting that value and solving the equation. In this case, it's saying, okay, our input now is 6. It's an f of x. So wherever we have an x value, we're going to replace it with 6, right? So here I would have 6 squared plus 3. Well, 6 squared is 36, plus 3 is 39. So what happens when my x value is x plus 2? Well, it's going to get more complex, right? Because what am I saying now? I'm saying x plus 2 squared plus 3, right? That's like going to get my value. It's going to be a little different because I got to go x plus 2 times x plus 2 plus 3. And then we're going to FOIL, which I hate saying anyways, you guys know that, but so we're going to distribute these through, and we're going to go x times x equals x squared, and x times 2 is plus 2x, 2 times x is plus 2x, and 2 times 2 is 4. And then we've got this plus 3 still on the outside. And then we're going to combine our like terms. And we get x squared plus 4x plus 7. This is your answer. This is your evaluation. Just because you didn't get a number doesn't mean we didn't evaluate. We figured out what that equation would be when x plus 2 is our input value of x. And you're going to see some problems like that. There's one specifically I know where, like, I hope you wrote that down or take a picture of it, because there's one on your homework that's almost identical, right? Which is why I used it. So think about that. It's got different input values, but this part is basically the same. So kind of understand how to use that when you're evaluating a function. All it means, just like when you're evaluating an equation, it just means plug something in. This is what we're telling you to plug in for that missing value. You tell us what you get back out. So let's see. Those are the two big things I saw in your homework, was the is this a function, and then the evaluate this function. The other thing that I saw was finding values when f of x is equal to 0. So if I have an equation, let's say f of x equals minus 2x plus 10, right? Sorry, can't see that. So if I have something that says, let's find the value when f of x equals to 0, and it gives me an equation like that, all it's saying is, let this equal 0. F of x equals 0, right? Minus 2x plus 10 equals 0. So all we have to do now is solve for x, right? We need to get x all by itself. And you guys have done that before, right? It's just an equation. Minus 10, minus 10. So I get minus 10 equals minus 2x. And then I can divide out this negative 2 on both sides, and I get x equals 5, right? That's all you have to do. You guys have solved equations like this multiple times, right? So when it's telling you to set it equal to 0, that's all you have to do, all right? You will see some that look like f of x equals x squared plus 2x minus 3. When I set that equal to 0, if I have x squared plus 2x minus 3 equals 0, does anyone remember what I need in order to solve that? I'll give you a hint. That x squared makes it a quadratic equation.
Are you saying you need the quadratic formula?
Heck yeah, I am. Heck yeah, I am. Use the quadratic formula. This one you might be able to factor. You might be able to do it without, right? Because I could probably break this down as x minus 2 times x minus 1 equals 0 and solve it that way. But if you can't remember how to factor it like this, right, because then I could set each of these equal to 0, x minus 2 equals 0, x minus 1 equals 0, and solve each of those. But if you can't remember how to factor, it is okay, because we have the magic formula, which is x equals minus b plus or minus the square root of b squared minus 4ac over 2a. I am going to get that tattooed on my body one day. I don't even need it. It's already tattooed on my brain. I should. It'd be my ugliest tattoo, like just a mathematical formula. As much as I think math is beautiful when written on paper. I'm looking, I didn't do any where you have to set them equal to each other. I took out the word problems for now as well, and evaluating a difference. So I think we've talked about all of the stuff that's actually in your homework, with the exception of domain and range, which I've talked to you about before. But what I want you to remember when you're doing your homework and they talk about domain and range is that the domain is your input, right? So if I look at this, your domain is what can X be, right? It's anything that X can be. So if I had something like, say, 2 over X, what can't X be in this situation? What would X have to be to disrupt the space-time continuum? Yes, thank you, William. Yeah, we can't divide by 0, right? So our domain for that would be all real numbers except for 0, right? What can our range be? If I look at this, there's nothing x can't be in this equation, right? It can be any real number. So my domain of that would be all real numbers, right? My range is my output. It's y, or f of x, right? This is x. This is f of x, or y, right? Notice that our range depends on our domain, right? We know what our range is based on our domain. We can't know what the range is at all until we have something input, right? So that's why they call this the independent variable and this the dependent variable, because this depends on that, right? And because our domain can be all real numbers, our range is also all real numbers, right? There's nothing that our, well, actually, in this case, there are things that our range can't be, huh? Because if I actually graph this, right, this is going to be 1, 2, 3, a parabola that starts here at +3, right? So what can't my range be on this one? I mean, we're going
Anything below 3.
exactly. So anything less than 3, our range can't be, right? Because our graph never goes below 3 for y, right? So our range in this case would be 3 to infinity. It would include it, right? So we'd have the bracket, and it would go all the way to +infinity. All right. Now, I don't know how much of that domain and range you're going to need in the actual homework portion of it. I just wanted you to have a basic understanding going in. Most of your homework is going to deal with either evaluating or finding values, or is this not a function? So take a look at it as soon as you get a chance. I'm going to stop this video here. I'll make sure it gets posted to PowerSchool. That way, if you need another quick run through for any of it, you'll have it at your disposal. And then if